Welcome to EDU World Space.
All right, so we have Mars with the diameter equal to 6,794 kilometers that revolves around the Earth. And that distance we're going to call S is equal to 5.58 times 10 to the 7th kilometers. All right. And we're going to look at Mars through a telescope with a focal length equal to 1.75 meters. All right. The question asks, how big, or find the diameter of the image formed by Mars in our telescope. So we can start off with our most used equations when we're dealing with mirrors. That is 1 over S plus 1 over S prime equals 1 over the focal length. Now, we can manipulate this equation to give us that S prime is equal to 1 over F minus 1 over S. Okay, now the reason we need S prime is because we're wanting to figure out the size, we need to know the magnification, and the magnification is going to be equal to S prime over S. Now we're given S in the problem. Remember, S was the distance from Mars to the Earth, or to our telescope, which was 5.58 times 10 to the 7th kilometers. All right, now using this equation, we can say that M equals S prime, which is 1 over F minus 1 over S. And then that is divided by S. All right, so if we plug our numbers in, we get that this is equal to 1 over the quantity, 1 over focal length, which is 1.75 meters. All right, so this is going to be minus 1 over S. Now, the important thing is our S given to us is in kilometers, so we need to convert that to meters. So that is 5.58 times 10 to the 10 meters. Now that's 10 because there's 1,000 meters in a kilometer. So that's an additional 3 order of magnitude of 3. All right, then that is divided by S again, which is the same thing, and it needs to be in the same units, which is 5.58 times 10 to the 10 meters. Okay, so this will give us that M is equal to 3.136 times 10 to the 11th. Now this is unitless. We can double check that by checking all our units. All right, so if we subtract these two meters, that still gives us a meter in unit. But when we take our meter and then divide it by another meter, we're left with the unitless quantity, and that's what we need. So m equals 3.136 times 10 to the times 10 to the negative 11. Sorry, negative 11. Sorry. Now, since we have m, I'll write that again. We have m, and that is equal to 3.136 times 10 to the negative 11th. Okay, we can solve for y prime. Now recall that m is equal to y prime over y, and therefore y prime will be equal to m times y. Now if we look back at our numbers, so m is here, that is 3 point, and it's unitless, so 3.136 times 10 to minus 11. Now we times that by our diameter of Mars, right, and that's going to be 6,794 kilometers. But since it is kilometers, we need to convert that to meters. So 6,794. Now to convert that to meters, we just go multiply it by 10 to the 3. All right, so that'll give us meters. All right, we'll multiply that out. We time is equal to 0.0000213, and that's in meters. Now, this is a lot of zeros to deal with, so we can also convert this into millimeters and say it is 0.213 millimeters. All right, thank you.